quite a while ago. I started with the F-35 project, creating some internal tools, and also a tool that helped decode error messages from the software. If there was ever a fault during testing, the software would dump an error message, and my tool would decode that and help understand what happened. Also then, did a double block at that time, so in the fall, I went over to A350 and learned a lot about electronics as well as software, because I had to work on the rotary magnetic encoder, which is a sensor that tells the hardware and software the position of the pump motor shaft. And that sensor is really cool, and it works up to 30,000 RPM. And when the motor is spinning very fast, it's still very accurate. So my job was to create the software to test the sensor and see if it would stay within tolerance, to make sure that it would work properly and the motor would work efficiently. I actually wrote the graphical user interface for the computer and code to go on the hardware that the sensor connected to, and they talk to each other, and the users or the operators who were testing the sensors would get a display of if the sensor is failing, something like that. The other cool part about it is I got this software out of version control software, so Monk has a repository for all the projects that they're still using, and what this means to me is that this is still being used 3 years later. It's something I worked on. It's so cool. Then last year in the winter was my third block. I worked a lot with the A350 group again. I worked on the Subversion server, trying to help them streamline version control and configuration management for their software. And also a little bit on flight software. There was a little problem with a chip from Texas Instruments, and they documented a workaround to try to avoid having catastrophic chip failures. And I had to implement that with help from more senior engineers, luckily. So that's still in the software as well. And then this time, I started in late November last year and finishing up tomorrow. I worked with A350 again, with Wally Machetes. And my main project was coding standards compliance tool. I had to take a requirements document that said exactly how the code should be written. I had to split that up into sections and make sure that each section was testable by a computer or a human. So some requirements were kind of vague, something like this comment should be clear and understandable. So that was something that's tested by humans. You have to read through code and say, yes, this looks good. Other things, like having specific sections in code that tell you exactly what the function is doing, that can be tested by software by searching through the code and matching it to a template. So I chose Python, which is a really nice, simple programming language. It's very versatile and it's used quite extensively at Moog and other areas. And regular expressions, which are a very good tool to match and search through text and match it to templates. So using that, I was able to go through source code files and pick out sections where there were mistakes or something didn't comply to a standard. So this tool was meant to save the software engineers a lot of time during code reviews. It would go through the code very quickly and tell them exactly where non-compliances were, instead of going through it by hand and trying to check everything by hand, line by line. So this tool is pretty new, and I think it'll be used more in the future. But it's already showing some promises. Then this is kind of the output here from the tool. It just says what source file, what line, and what the problem is. Kind of very basic. It doesn't fix anything for you, but it alerts you to where the problems are. Because if it was fixing something, it would have to go through a qualification process, and it wouldn't be ready to do anything yet. But it is in use right now. In fact, I got a lot of feedback from my initial prototype and improved the tool according to those, helping with output formatting and adding additional requirements to be checked against the source code. As I said before, the tool isn't complete, but it covers a big part of the standard, and I think I might have to support it a little bit in the future and help them out. All right. And the final couple of weeks of my co-op, I started trying to learn how to be a systems engineer, since my computer science major isn't quite usual for that position. But I've got a lot to learn, and starting with the basics, with learning Simulink. It's a model-based design software. You can create a system and simulate it in real time and see how it behaves. I'm used to writing a lot of code in MATLAB. This is actually part of the simulation for a formula that I was talking about. This calculates the corner weights on each, the weight on each contact patch of the tire to try to figure out what kind of grip the car has. But I'm used to something like this, whereas Simulink is completely different with a model. So it's a completely different way of thinking about how things interact and how the software behaves. So while learning Simulink, I was put in charge to looking into automatic report generation. The idea is that if the model contains the design information for the whole system, you can press a few buttons and you have a report generated directly from those definitions in the model. So all of the design information is stored in one place, instead of having to keep different documents updated manually. So I found some things in about the report generator, and I'm going to pass the knowledge on as I'm leaving, but I'll come back. Hopefully it's all ready to go, or if not, I'll pick it back up. Or I might be out for the summer, in and out, between competitions. So we'll see how it goes. And also, another idea along those lines of having everything kind of synchronized in one place is integrating Simulink with the requirements tracking software, which would kind of connect the design of the system to the requirements, both the high-level requirements from the customer and down to the lower-level requirements of individual subsystems. I guess, yeah, for the future, my schedule is going to be fairly busy in the spring quarter, but with the Formula SAE team, I'm going to 3 competitions this year in Detroit, Nebraska, and Germany. We're hoping to do very well with this car. It's very ambitious. It's a much lighter concept. We have wings to generate aerodynamic downforce, and it's going to be quite a test of what the whole team can do, how well we can do it. And once I'm done with that, I will be coming back here in September to start full-time with Military Systems Engineering Group, right?
Yep.
So that's it for the presentation. Do you have any questions, comments, concerns?
I do.
All right.
Who funds the race car?
Well, we get a lot of. It's not going fast enough, but we get a lot of sponsors from around the area. We get a lot of machining sponsorships. We get a lot of material sponsorships. Moog actually sponsors the car. I believe it was a monetary donation last year. So the school definitely gives us a lot of money, helping with shipping and just general spending. But we have to go out there and ask for money to be able to build this car. And as you can see here, this is a carbon fiber composite monocoque chassis. So that would normally cost a lot of money to make. Carbon fiber is extremely expensive, but fortunately we got the material donated to us, and so we were able to increase the chassis stiffness and also decrease the weight a little bit. So we're working forward with that this year and improving. That was our first carbon fiber chassis, and we're going to have a lighter, better one this week.
Hi, Don Davis from HR. Is there anything that you learned from Moog that you were able to transfer into helping improving the design of your vehicle?
Definitely. On my first golf, when I was working with the rotary magnetic encoder, I was also working with the DSP, the digital signal processor, to try to make those two things interface, and then also talk to the computer. So I learned a lot about working with oscilloscopes, first of all, at the very low level, and then also the serial communications interface to try to connect the computer and a microcontroller. Because on the car, we have a microcontroller that's responsible for displaying engine parameters on the steering wheel so that the driver can know if the car is overheating or if the oil pressure is low. So that was definitely very helpful for me. It was definitely very, very interesting that as a first-time co-op with no electrical background, I was kind of given a little bit of freedom in the lab, and I didn't break anything, but there's always that fear.
You haven't tried hard enough yet.
I was playing with expensive things.
Did you take a lot of vehicle dynamic courses before getting
No,
SAE?
actually, I haven't taken any courses in school about vehicle dynamics.
Where did you pick up all your vehicle dynamics knowledge?
There's a seminar put on by a company called Optimum G that is, I think, $400 for students in FSE competitions.
Yep.
So it's a 3-day seminar that me and a few other people on the team went. It's pretty in-depth. It's pretty challenging. But most of it is really just kind of thinking about how the car works and talking to other people and trying to build it up from basic physics.
Do you guys subscribe to the SAE tire testing consortium data?
Yep.
Okay, I used to work at Calspan, so I tested some of those tires and collected that data. And I'm actually, do you know Edward Kasperzak or Millikan Research with Doug Millikan? So I'm doing research with Edward right now on vehicle dynamics and programming models. And Moog donated the smallest motion simulator platform. So we have half a car on top of that we do virtual models on. Simulates driving.
Is that for UV?
Yep.
That's cool. We'd love to get one of those.
Yeah, it's pretty sweet.
Motion platform. Yeah. I'll have to come check it out. Okay.
So, what was it about your co-op experience here at Moog that made you decide to accept a full-time offer? Because I know we weren't your only offer.
It's true. Well, throughout my time here, I've always been kind of impressed and intimidated by how smart all the people around were. Everyone was always nice, answering questions. And, I think it's going to be a really big challenge and a learning opportunity for me to try to figure out what systems is all about.
Do you feel like now, since you overcame your fear of electronics, that the rest of what's in systems is just a matter of time?
It's definitely, a lot of it is time, but it's also brand new to me, so you never know, but I'll give it a try.
Any other questions?